Hello folks, today as you can see we're talking scale, specifically the FunKey 50 or 600 size Bell 222 or Airwolf. A reoccurring question that I keep getting asked on my site regarding scale builds is what is involved in the Bell 222 or Airwolf 600 ESP mechanics, fitting them, all that good stuff, and is it a hard build? Yes, you know what? Out of all the FunKey models in the 50 to 600 size range, or the 50-600, the Airwolf is probably the hardest. Main reason for that is the retracts. They're a real pain in the ass. But there's also a fair amount of fuselage modification. Not tons, but enough that it might scare a few people away or be quite challenging. Again, this all depends on your modeling experience. You know, if you're an experienced RC modeler, either aircraft or either airplanes or helicopters, yeah, you know what, you're going to be able to tackle an Airwolf or a 222 no problem. So I just want to show you what's involved in it. I had to have the mechanics out of the Airwolf here for some maintenance. So I'm just going to show you my method of mounting them, a few little tips to be aware of when you are building one of these things, and hopefully it'll give you a better idea of what's involved. To see if you want to tackle it yourself or maybe wait till your second scale build. Anyways, we'll get right to it. So we're going to start at the mechanics. Sorry, this is going to be freehand, but it's about the only way I know how to do this. As far as mechanic modifications go on the 222 or Airwolf, first thing you'll notice, this bulkhead. This used to be a one-piece bulkhead. The plywood spanned this distance. You have to cut that out because the mechanics actually sit back in here a little bit, and you need that clearance. Otherwise they bang in there. And then what I do is I glue or epoxy a 2mm carbon fiber reinforcing plate in here. You could use plywood again probably, but the carbon is strong, and it obviously brings back the rigidity that you lost when you cut that out. I'm going to go over these mounting plates in a little bit. I'll show them more with the mechanics. But I use a floating mount now. I don't have rigid mounting anymore, and all that means is this is a foam rubber in here, so it's quite flexible, and what that does is it allows, or it prevents vibration energy from the mechanics migrating into the fuselage. You know, you're still going to get vibration in here, but it absorbs a lot of it, and it really helps reduce the vibration getting to the fuse. Fuselages essentially are vibration or resonance chambers, and little vibrations when they get into these, if they match the natural frequency, these things can shake themselves apart. And since I've been doing soft mounting, I've never had a problem with that. I used to mount hard mount using wooden blocks and stuff, but I've gone to soft mount, never go back again. The other thing to consider are your servos. They have to be a low profile to fit in there. Now these aren't low profile retract servos, these are low profile aileron or wing servos. There's just not enough space for a standard height one. And they can't be retract servos. Retract servos are full throw either direction. You can't slow them and you can't set end limits on them. And I also use analogs because if they were digital and they stall out, which is another thing we'll get to in a bit. You know, the digital servo will draw a lot of current, whereas the analog won't. Now, as far as the retracts go, as I said, they are a pain in the butt, especially if you're controlling them all from one channel, because essentially what has to happen here is each of the retracts have to have identical geometry so they don't stall out either in the up locked position or the down locked position. And there's 3 servos, one on each winglet. There's one there going upside down, and then one at the front nose wheel there. And again, they all have to have exactly the same geometry, because if you're controlling them with one channel, you need the end points to lock them all in the up position, and in the down lock them again. And the movement is very precise, and it can take hours to get it configured right. An easier way would be to actually, if you could hook up each servo to a separate channel and then mix all the channels to one toggle, and then you could independently set the travel range for each servo. Likewise, if you had digital or programmable servos, or if you had a servo sequencer that you could adjust end limits on it for each servo. As far as servo sequencers go, I don't really have one. I've got one of these little Turnigy, this is a servo slower and reverser. So if your radio's got servo slowing, you don't really need this, but one of these servos has to be reversed. As you can see, I've got all my wiring in for my lighting. Just try to run it as neat as possible, tacked it down with hot glue. And the only other thing on the big mod on these is the actual doghouse. Now these come as one unit, but you actually have to cut them. And I use a Dremel cutoff disc for that. There's basically, and the reason you need to do that is when this is on, you need a way to access the battery, which is right on the front of the 600 ESP mechanics. So you need a way to get into that battery. And that's why that's why you need to cut that doghouse in there in half. Some people will actually cut it on this seam line. I don't like doing that though, because that compromises the strength of the doghouse, because your seam line is through through the top swash plate hole where the rotor mass comes through. Now I'll just go over the mechanics. So that's the main mods you have to do with this. And doing this isn't exactly easy. I use a fine or a thin Dremel cutoff disc. You have to have a steady hand, and you just cut along the seam line. Be very careful. And then once you've got it separated, then I'll also use epoxy to reinforce the cut, and I glue three little locating pins. These are just little carbon fiber rod. I'll glue them in here, and then they slide into, let me get this out, hopefully you can see this, they slide into these little holes as well to hold the two halves together. And again, on the back half, again, I've reinforced that cut with epoxy and fiber filler mixed in with the epoxy. It's basically epoxy with a fiberglass powder that's mixed in with it. Again, that just gives it a lot of rigidity. If I didn't have that extra fiberglass reinforcement in there, this would be really easy to bend and flex. Again, this is just my method. There's other methods, of course, but this seems to work the best. So that's pretty much it for the modifications to the fuselage. Really not that bad, just the back bulkhead, and then this cutting the doghouse. So we'll get to the mechanics now. Okay, now as far as the mechanics go, again, these are 600 ESP mechanics. I try to have all the wiring contained in here. So any plugs or anything are on here. It makes removing this really easy. You're not worrying about, hidden plugs while somewhere else in the fuselage. Everything easily plugs into this. Up front, here's my Castle ESC plug. I've got it right up here, so I can plug this into my Castle link to either change the parameters in the ESC or download the data logs. This is from my receiver. This just hooks up to the battery telemetry sensor for my LiPo pack, for my flight pack. Again, everything's contained in here. The antennas, I've got little Velcro mounting pads inside the fuselage that these will stick to. And if you've got a flybarless unit, this is just an old 3G, fine for scale. I've got the 3G programmer plug right up front so I can access it, because basically everything back from here you can't get to once it's mounted. And you just want to, obviously I recommend flight testing it in pod and boom format first. And here are these plates I was talking about. So I've just used carbon plate. You could use birch ply. And I've got it, so the plate is screwed to the ESP mechanics, just like the landing struts would be. But this way then I've got these two holes a little wider apart, and they're really easy to access when they're in the, when you're dropping this in the fuselage. And you'll see that when we refit it. And as far as the mounting block height, I'll get into that a little bit when we refit it. But if you're going to do anything, err on the side of a little too thin, because then you can always add spacers. As you can see, I've had to on this back plate to raise the back plate up a little bit to get my angle right. Whereas if your spacers are too thick, then yeah, you've got to shave something down and basically restart all over again. So err on the side of too thin, if at all possible. As far as the tail boot or the tail rotor goes, this is another trick you're going to have to do. These will have the fin mounting holes, or the mounting for the fins. You generally have to shave them off a little bit for them to fit inside the scale fuselage. And you're not going to be able to use the crimp anymore. What I do is I have a single screw that holds this to the boom. Here's our boom. Let me just bring this around, show you how I've got this configured. So this will just slide on, because you have to put this in after the boom is in the fuselage. So, and these are covered, these are hidden, you can't get to them, so I've got a little hole in the back of the fuselage boom to get that screw through, to screw the housing of the tail rotor assembly right to the boom, using a short M3 hex screw. You don't want it too long because it'll hit the torque tube. And inside, not enough room, I don't know if this will show up. Probably not, because it's pretty dark and it's in there. But this is actually threading. It's not just threading into the aluminum. I've got a M3 lock nut in there that I've metal epoxied right to the side of the boom. So that's what's holding the tail assembly to the boom, is this little screw which goes into that metal epoxied nylon lock nut. And that's about the only tricks. So it seems simple, but when if it's something you've never done before, yeah, you have to think about it a bit. So now we'll mount her in. So the first thing you have to do, another reason these are hard is because the whole front section doesn't come off. So it makes fitting the mechanics more difficult, because you have to drop them in. You have to fit the boom first into the back end, drop the mechanics in, slide the mechanics forward, push the boom into the mechanics, tighten all that up, slide the mechanics back, bolt them into the plates, and then fit the end of the tail rotor. So we're going to fit the boom first. Here's the boom donut. I like using these little, they're these push rod guides, and I just chop the push rod guide off. So you've just got this little clamp back here. You could probably use anything as long as it clamps around the boom, and that just keeps the donut from sliding too far forward as you're pushing it back into the fuselage boom. You have to cut a little hole in the donut for the push rod to go through. It's another reason ESP mechanics are nice, because they've got the flexible, it's a thin little metal push rod that flexes a little bit. Probably couldn't get away with this with a carbon rod. Maybe you could, maybe you couldn't, but the little metal rods work well in scale. So we're going to put our, and the servo's already mounted, of course. So we're going to slide that back into the fuselage first. No, I'm going to have to put this in after the donut. I forgot the horizontal fins back here. I've got little carbon plate in here to keep to increase the rigidity. These actually come with a little the kits, the FunKey kits come with this little it's kind of this horseshoe shaped plywood that you can glue in there, but then you don't have much room to work. So what I normally do is I glue a piece of either carbon plate or, again, birch ply just to the side to, you know, increase the strength around the horizontal fin, and then when you mount glue the fins on, they're nice and strong. So again, we're going to slide this in there. We'll keep the donut out for now. So slide it all the way in. Now I'm going to grab the mechanics. When you first, you know, before these are even glued in, these plates, you know, what I do is I'll make the matching plates. They'll be all screwed together. I'll have the foam glued on the bottom. But before I even do any of that, I will have trialed fit this several times to get my height, my boom angle, and then I'll just keep adding, you know, spacers underneath, generally the front, because the boom is going to be supported by that donut in the back. And then you can just raise the front of the mechanics up and down to get your level, you know, have it centered in. You're going to have to put the doghouse on so the mast is centered, you know, right in the center of the doghouse hole, just to give you, to get you started. Then you'll know what height you have to make those spacer blocks. And like I said, I had those all glued together, bolted. I use Goop Glue. It sets up, it doesn't set up as quick as, you know, you could use a 30-minute epoxy. I find epoxy though can sometimes separate from the fiberglass if you don't clean the fiberglass really well from the release agent. Use acetone or something and really scratch it up or scarify it with, you know, an 80 grit sandpaper or something. The Goop Glue, it doesn't set up that quick, so it gives you lots of working time. And Goop is flexible and it really adheres well to both the foam and the fiberglass. Again, you want to clean the fiberglass with acetone or something similar, just to get any release agent off of there. So now we'll just fit the mechanics. Let's see how this is going to work. So they're in there now, but I'm going to slide them forward, and then we're going to get the boom and slide it into the back end of the mechanics, hopefully. Okay, there we go. Just push them full forward. Got to put our 4 screws in on our boom mount here. I'm just going to pause it while I get those. Okay, another tip here. There's lock nuts on the back side of this this plastic boom mount. They easily come out. So what I usually do during a build, I'll just put a tiny dab of medium CA on one of the sides of the bolt, the lock nut, when I press it in there, and then it's stuck in there. It's not going to come out. Then you're not going to have to worry about them falling out as you're putting the screws in. So we'll just fast forward through this. Actually, I'll just do one. You'll get the idea. Okay, so we've got the boom mounted to that boom block with the 4 bolts, the M3 hex bolts. And that was with the mechanics slid full forward. Now I'm going to slide them as far back as they'll go, basically to that carbon reinforcing plate on that rear bulkhead, just so the boom is just visible through the back here. So the first thing now we've got to fit back here is our little donut, the boom donut. How many times have I done this and then I realize the boom donut's missing? This can take a little bit of finagling. You gotta get the push rod through. Come on. Okay, so I've got it slid in there. There's the donut around the boom. Push rod's coming out through the bottom. And before we fit the tail drive though, we're going to mount or put the 4 bolts in those plates to get the mechanics securely mounted in. Mechanics are slid in. Those plates are lined up now. I don't know if you can see it here. So there's the hole in the one plate, hole in the other on that side, and same at the back. A little harder to see. That one's easy to see actually. That one's easy. And now you get an idea of why I make those plates a little wide. They're really easy to get the bolts into now. You just need a long hex drive. They'll go right in. And I should mention on the back side of the plate, like the plate that's glued to the foam, on the back side of it there's again a metric lock nut, a nylon lock nut, and I've got it, I've used metal epoxy as well to glue it directly to the carbon plate on the back side. So that's why you don't need to worry about having a wrench or anything underneath. And this way the bottom of the helicopter, there's no holes or anything, because that foam is just glued in there, and you don't need a hole going through the bottom to hold a nut on the back side of the plate. The epoxy is doing that. So you just get your long reach hex driver to get your M3 hex bolt down in there. Hopefully that's showing up. And really easy to access all those four. And yeah, that's why it's nice taking a little bit of extra time to make those plates, because then it makes removal and refitting super easy. I was just going to mention, like right now we've got those glued in. This is set, but say you were just trial fitting it for the first time, you'd have that foam in there, and that gives you the ability now to move. You wouldn't have that glued in there if you needed to add spacers to bring it up or down, and then fit your back half of your doghouse. Make sure your mast is coming up through the center of the hole. When you get yours, these little cutouts won't be in here, so you have to have the swash plate down. Just have the mast coming out. Just measure. There won't be these little round cutouts in here for the swash plate ears. This will just be a nice round circle, more or less. So you're going to have to get a Dremel with a sanding drum in there to cut out these little notches. So the swash plate, your 3 ECCPM swash plate ears, will clear the little openings in the doghouse. And you can see right here it's pretty tight. I actually had to grind a little bit out for those frames to fit in. The Phoenix Tech 600 ESP mechanics I sell, they're a little bit wider. They're 54 millimeters wide. These are 47. So you're going to have about 3.5 more millimeters of width on either side. And to accommodate that, you might have to drop the front of the mechanics down a little bit more. So you're going to have a little bit more of an angle, tilted angle to the front. Or what you could do is you could take that frame bolt out, and you could either move it down or move it back, so you don't have those screws there. You could even notch or file down the corner of the frames. But I know it fits. You might be wondering what this is. We'll get to that when we talk about the battery. Okay, so another component that you will find in the FunKey 222 or Airwolf kit are these little aluminum braces that go on the side. And any scale build, you also want to support the upper half of the mechanics in the fuselage. So, as you can see, these would wiggle around a lot. A lot of that has to do, of course, with those floating mounts, but that's also just play in the bottom of the fiberglass as well in the fuselage. So you need something to hold that from moving back and forth, and you have to size these little rods. And I bolt them into the back screw hole of the bottom main mast bearing block. And I'll just fast forward through this one, but you get the idea. So once those are bolted in, then this is held from moving back and forth inside the fuselage. And yeah, you do have to shape these, you have to bend them at a slight angle. You could mount them anywhere. I just find, right at that back block is a good place. You could go higher, you could make a separate screw hole, mount them a little further back. It's totally up to you, but the main thing is you have those braces in there. So we'll just fast forward through this. Yeah, so here's another little tip. Any wiring that you have to connect to your mechanics that comes from the fuselage, it's nice to have really easy access areas. So on this particular build, I've got my 3 plugs, So the first one is your the tail servo. We'll plug it in right now. Just makes it easy to access and also easy not to forget something. Okay, the other one is lights. That's this one right here. And the last one is the landing gear. Okay, so those are all easily fit. Okay, so we're back. Just mounted the two PCB antennas. There's the horizontal one. And on the other side, where is it? Right there, there's the vertical one. Right there. Got the other brace mounted. Okay, so it's nice and rigid. So before we put, now what I would do, if this was a fresh build, we've got to get the tail rotor on. I'm going to show you what's involved there. It's pretty simple, but there's a few little tricks. I would fly this now without any of the doghouse on. You know, I'll mount the rotor. I would mount the rotor head, get the battery fit. We'll go over that real quick. And you know, it's just one less thing to break if you've got a big vibration in here. If this mast starts oscillating, you know, you're not going to take out the doghouse. Yeah, it's just a lot safer having this open, and you have access to a few things if you need to get to them, if you see anything weird going on. But we'll do the tail rotor right now. Should mention there's a strobe light on the bottom of the tail fin on the 222 and the Wolf. To get the wire through there, this fin is not normally mounted, you know, it comes separate. What you do is you just drill a little hole at an angle. This is hollow, and then you'll have to drill a hole through the light pod as well into the fin. But again, this is hollow. Just be very careful. Use a small drill. Don't go out through the side when you're drilling this one. Then just use a piece of mechanics wire to fish through there, and then you can pull the wire through. So here's our tail rotor assembly, and we'll just slide that on. Hopefully. Takes the wire out of me. Oh, there we go. Now, the other thing, when you get these, there's not going to be a hole in here at all. So you've got to get your Dremel tool and just carefully keep going at it so you've got enough clearance for all your tail rotor mechanism. You need it for these, you know, the pivot arm and underneath. There, let me just twist this so you can get an idea of what's going on under there. You know, you have to elongate a hole there as well for the push rod clearance. And if you noticed, I've got a little hole cut here. This is that screw that holds the tail rotor housing to the boom. That goes into that lock nut that is metal epoxied to the inside of the boom. When you metal epoxy that nut, you have to use a Dremel to scratch up the inside of the boom to get the anodizing off, or the epoxy won't stick. And that screw has to be, you have to make sure it's not too long, or it will hit the the torque tube. There's probably other ways to do this, but this is an easy way to keep the stock tail rotor. You don't have to buy some special scale tail rotor assembly, and then, you know, just glue that bolt in there, or that nut. Super easy. Last thing on here is to fit our push rod. Snap the link back on. Good stuff. Then you just fit the end cover on. There's the kit comes with little screws. They're the 222 or the Wolf. They'll be painted. The head of them will be either black, whatever color, so they match real nice. Hopefully that's showing up. I don't have to show you how to do that. It's pretty straightforward. There's just 3 screws, and we'll just do the one here just to give you an idea what's going on. Let me guess I don't have my right Phillips driver handy. There we go. Hopefully my big fat paw isn't in the way. And you don't want to, you don't want to McGill those, or you'll crush the fiberglass and strip out. They're just threaded into a little piece of wood, plywood. I usually get some thin CA just to, and I put it on that plywood just to strengthen it so it doesn't strip out as easy. Then you just want to make sure nothing's rubbing on here. Your pitch slider's working. I'm just going to pivot that up so you can get an idea of the whole cutout. Turn that rotor a bit. So you can see why you need that big opening at the bottom there, just so the push rod doesn't interfere. And we'll just show the battery now. That's the last thing. Now, the battery. So the whole reason, the hardest part of this is cutting that doghouse open so you can access the battery through here. Now I've seen people, they've cut hole through the doors, and there's various ways to do it, but by far the most popular way is to go through the top of the doghouse. Again, you can split it back here if you wanted to, but I like splitting it up at this seam mark. You've still got lots of room to access the battery. Again, there's my Castle. I can disconnect my ESC for my Castle link right there, and my plug for the telemetry for the battery, the flight battery. Here's the ticket I made. Now there's various ways to do this, but I just made this little battery cradle. It's made out of, what is that, 1mm carbon, I think, plate. You could make it out of anything you want, but it's basically just a little chair. And the idea is the battery just fits in it, strap it in, and then I've just got these 2 little sliders on the back. They'll slide in between the frames, and there's this little pin at the bottom, and I've got a carbon plate on a wooden block at the bottom that pin slides into. So this won't pivot forward. And then on the back I've got a little hex bolt there that I thread into that rod. Now this rod, I just bought some aluminum rod, bar stock from the hardware store or hobby shop. I just cut it to the right length. I threaded it so I could bolt it in there, and I put a hole through the center for this screw on the cradle. And oh geez, I don't have my hex driver, but the idea is you just slide it in, and this is what would be involved in a battery change. So it just slides in, and then you just screw that in. And now that battery's securely mounted in there. It's not going anywhere. Super easy to change. To plug it in, you would just plug her in. And if you wanted to hook your telemetry up, you'll just slide him in there somehow, and then you would fit the front of the doghouse. I have a screw here that holds the doghouse on. Again, I've got a nylon lock nut on the back, or a lock nut on the back that I've epoxied in there so it doesn't spin when I tighten this down. The other thing you could do, of course, is just to get a couple of strong rare earth magnets and glue them on both sides to keep that hatch latched. And at this point, you've just put the rotor head back on and go for a test flight. But again, if this was your first time test flying this thing, I would leave the entire doghouse section off, just in case you get the bad oscillation up here. This is going back and forth. You would damage your doghouse if that were to happen. So that is how to fit 600 ESP mechanics to an Airwolf. Hopefully that helps anyone out who's thinking of doing this, to kind of give them the idea of what's involved. It's not super difficult, but it is time consuming. Take your time. That's the best advice I can give you. You know, if you have to walk away from it, because it can get frustrating, walk away for a few hours or a day, whatever, come back. Just take your time and it should go okay. Cheers, folks.